who is the person who is willing. I mean, you have to think of the group as a whole. Okay. And also, since you are a large group, earlier when I started here, we had only 17 students, 17, and today we have 70. So it's a large group. So the convener has to be somebody who also thinks of the his or her individual thing or his small hostels groups or something, right? I mean, it's so based on that you can always choose somebody. So just give me one name. I just want a mobile number, and in case there is anything, I will contact. Maybe one possibility is this is your second year, first semester, right? So maybe you don't know each other also. I don't know.
Yes, so that's also true.
Give me any one name. It's fine. I mean, for the time being, anyone who wants to take initiative. I mean, I'm fairly easy to get along with. It's not that, giving this name is in any way hurtful to you or that it will lead you to any sort of difficulties. Okay.
So I guess what we can do is just like we can discuss it among ourselves and tell it to you by next class,
I
if
got a
possible.
message here from Devapriya. I don't know, DP, acting conveners. It doesn't matter, right? I mean, it is all right. So Devapriya, then all you have to do, I'm just going to put your name here. That's number 16 in my list. Sweet 16. 16 is a very special. Wait, Devapriya. Okay. So just give me a telephone and an email. Send it to me. Wonderful. Yeah. 2708. Just a minute. All right. Now, what we have to do, the first thing generally in this course is what you already know. We are supposed to do, we have to take the dimension, we are first supposed to do a dimensional analysis. Now we have already done that. So what I suggest is, why don't you take the usual MLT dimensions and just tabulate for the usual things starting from the least complexity like we normally do in physics. So we start from velocity, then we go to acceleration, then we can go to force, then work or energy if you will, if you want to term it that, and then power, etc. And then what I will do next class is just take up some specific say variable which comes in chemical engineering or chemistry which you are familiar with, and then ask you, well, what are the dimensions for that? So that will just tell me that, okay, it's something that all of you are able to do. Okay, so that's what we have to do in class 1. The second thing is we have to finalize this attendance list. Maybe I can download it. You have to just tell me how that is, because I have only 16 names here, but now this is showing 58. Okay, so that's when, because 10%, and then the first attendance we have to mark. The third thing we want to do is, what is the weightage for you? It's the usual 30%, right? Now 30% is not difficult at all to get for passing grade and for audit, right? So that is the same. So what is it that we are going to do, and what are the textbooks? So I may spend a couple minutes, and I want to tell a couple things about your instructor, which is myself, right, Sunil. So normally, so we start with dimensions. That is just one class today. Then, you know, the type of balances that we can do depends on the type of process. So we just delineate the typical categories of processes on which mass energy balances can be made. Okay, so that's something that we have to do perhaps today, tomorrow, or Wednesday. Then, depending on the type of process, we can write a general type of balance equation. Right? I mean, we have say we represent that process by a black box, a rectangle, let us say, and then we identify all the streams of all the components that are coming into that black box, into that rectangle, and then we identify what are the streams that are going out. And then if it is a certain type of process where there is steady state, nothing accumulates, but if it is not a steady state process, something accumulates, then we have to label inside that process unit also what is happening inside that box, what is accumulating, what material, and we have to label all these components and streams. In other words, if you have a 1 hour exam, if you start writing all the equations, suppose there are 10 components. Now, I'm not saying I'm going to give you something like that to solve in 30 minutes or half an hour or 1 hour. But suppose you can always, in principle, do it by a brute force approach. You can balance, suppose you have 9 components, you can write 9 component balance. But who is going to solve it in that 30 minutes? So it's not sufficient because it's a calculation course. So you need to reach a final answer. And one rule that is there, which is like an unwritten rule, is if you get the answer wrong, you only get half the marks. So essentially, it's very easy to score half the marks. But you have to get the correct answer for full marks. So, I mean, I just want to spell it out right away, because later you shouldn't say, sir, my approach was correct. So, there is approach, तो इसमें बहुत लोगों का correct होगा. Because as I said, the principles are similar. Let us say we take the simplest type of process. Nothing is accumulating anywhere, nothing is absorbing anywhere, nothing is reacting, non-reactive. So all you have to do is balance input by equal to output, right? So the principle, so if you just write that equation and say I was on the right track, it's not sufficient. That just gives you half the total marks, okay? So the rule is the same for everybody. The answers are important. Now, we do not stipulate this in many times in other courses. There are partial marks for every step. But here, if the answer isn't right, you get only half the total marks. And it doesn't matter where you went wrong. Maybe last step you wrote it wrong, whatever. But so this is so basically you have to work reasonably accurately. All right. So is that okay? I mean, I want to spell it out because otherwise you will bring me your paper and I don't know how this is going to be done online and then say, sir, mera to sahi tha. I do not want to get into this at all. Because there is no solution to this problem. finally, the fact remains, if you, for instance, join any consulting company like a lot, or have your own startup, finally, when you do any report and you want a final answer, you can't say that my steps were all correct, but my final recommendation जितना इतने tons per hour आपको manufacture करने हैं, वो उसमें गलती हो गई. I mean, you have to get that number right, actually, right? So here, there is always a definite answer. Of course, you have to interpret the problem statement correctly. For instance, when they say what is meant, is it in the gaseous thing, is it the liquid thing? So what is being asked is the sum of those two. You can have a liquefaction process as in distillation. And many times, so you have to interpret. So in that interpretation, if you get wrong, you will get the final answer wrong, but that is only 50% of the. So it's not that you get nothing, but you all get the 50%. But the correct answer is also important in this type of course because it is calculations. Earlier, we used to call it bioprocess calculation. Now it is mass and energy balance, but it's similar, right? Okay, a little bit about myself. My BTech is from IIT Kanpur, as I told you. A very special institute in my time. It was a 5-year BTech. I mean, I have always been a topper in from class 1 till, and then including higher secondary, and then I had a high 3-digit rank, and then chose chemical engineering, which of course during ragging they don't like. Why did you not take electrical engineering? You know, we have this hierarchy or whatever, you know. And then of course, then a topper at IITK also. So in a way, it was a pretty difficult task because in IITK, you know, there is no other thing. It's not like a city culture anyway. So then afterwards, all my further studies are done abroad in USA and in Germany. And I'm among the first few chemical engineers who moved into biological systems. So you see, in the 1980s, this was a rare thing. Chemical engineering, petrochemicals, polymers, and all the things that this industry, oil, gas, etc., had built was at its, you know, it was a heyday, and the biological things were very not looked on as something. Nobody ever thought that biological systems are very important. That this is indeed true in the 70s, 80s. And today, all those departments where I worked in, which were purely chemical engineering departments, all of them, without exception, all of them are called chemical and biochemical engineering, or chemical and biomolecular engineering, or chemical and biological science. I mean, everyone has, or material science and bio, they all have converted. So it's funny. I mean, in 30 years, everything has changed, and all the dharma sankat that I had to go through today, it's just accepted. I mean, no, everybody said, why would you want to change to biological systems? But then that's exactly what I did, and so it required a lot of, you know, you have to stand for what you really like to do, and it's never easy. But now we take all of this for granted. Okay, so can you, meanwhile I just finalize the list, can you all just quickly work on the dimensions part? And if there is any question, I would be happy to take it up. And I will just test you on something. I mean, there are so many variables. And once that is done, what we want to do is in the first month and a half, focus on pure mass balance, the simplest type, without any recourse to, I mean, there are no energetic changes taking place, no changes in internal energy, no changes in enthalpy, no change in free energy, no reactions. Okay, so that's what we are going to do for the first 5 to 6 weeks. And this we do after we have written down what are the typical typology of processes. Okay, because you have to know, is the process in steady state or it's not, etc. Now I see a number of messages. I'm just trying to see, do I need to read those or? I don't know, it's disappeared. Okay, so after we have the category of these processes, right? Then what we will do is write the general balance equations, okay? And then we have to see how to put all of that in the form of a diagram or a flow sheet. This is very important because otherwise, if you write everything in text, it will take too much time. So we'll do that for some simple problems and then go on to add more and more variety to the problems. And what I would like is that we try to solve those questions in class itself. Then that way, you're already prepared. Any process can be asked and you will be able to sort it out. Otherwise, what will happen? We do the principle, then you will go and then go back, and then there's no need. We can do this in the time here itself. Now, the good thing is there are many books available for this. But anyway, so I just told you the first 6 weeks. After we complete the mass balance, we go to energy balance. First, we look at non-reactive systems. The non-reactive systems. For instance, suppose you take NaOH and water. We know that when we mix them, so once you mix them, you know that energy is released, heat is released, and then how do we measure all of these things? Of course, you need data, but suppose the data is given, how do we find those energetic aspects? Now, these are somewhat simple because they are just two components, no reactions taking place. Now, things become more interesting if we add a chemical reaction to it, because as you know, chemical reactions are all endowed with energy changes, enthalpy changes, free energy changes, etc. So what sort of heat effects do those lead us to? That is one reaction. Suppose now I have two reactions. Things become more interesting. Then to that, say I have multiple chemical reactions. So many times from Hess's law type of things, we have to be able to work out the entire energetics of multiple reactions. So the problems can become more and more complex. And then in the last part, we go to biological systems. Now here, the material is not as well, there are no such great books as we have for the chemical part. So for the first 2/3 of our course, we have very nice textbooks, and I'll give you some of them. You can consult them or acquire them. But when it comes to the bio part, I think we have to, you have to take down notes or something like that. Would be probably best, because the books are not as comprehensive and not as the clarity is not there. Different books do in a different way, and I've never found an ideal one yet. Anyway, that comes much later. And you know, this time we have it's a weird semester. We have a semester break from 29 November to 13. Now I am out from 13 to 26, so 2 weeks. So that means 6 classes. So 6 classes we have to make up before 29. So we'll have to take one Sunday. Okay, because I already know my schedule for December. So we will need to do 6 classes, maybe after we complete the mass balance of chemical systems, after we complete the energy balance for non-reactive systems, and then go to reactive systems energy balance. And then we will have, let us say, 6 to 7 classes on the bio portion, and then we will have about 4 classes left, and there you will present that 20% of the project or whatever the flow sheet or the process that you have chosen as a group of 5 to 6. So I'm back on 27th of December, and then we have time till January 4th or so, and then you have to present that thing. So this is, so I thought I should just tell you this right away. So we will need to have 1 or 2 Sundays where we make up 6 to 7 classes. Devpriya, what do you say?
Yes, sir.
Is that all right?
Yes, sir. Yeah.
Okay. Anything that anyone would like to ask? Is the way the books? I forgot about the books. So let me just give you that. Now, the first part are wonderful books. I mean, first 2/3 till November 29th. Whatever we do, I think we have wonderful books. So 2 books in particular, which you can consult any one of them. The first one by Himmelblau, Himmelblau. Himmelblau. The second book by Felder and Rousseau, Felder. I will give you the titles. These are the authors, Felder, Felder, and Rousseau, Rousseau. It's pronounced in the French way. The EAU is ou in French, a language I know, a language I speak. So Rousseau, the titles are all almost the same. One is called, I don't remember which one is called, Principles of Chemical Processes. That is called Chemical Process Principles or something. You will be able to find it. The latter book is a John Wiley press. The first one, you will find both of them. The Himmelblau book is very, very thick, has too many problems. The second book is little more simpler, not as complicated in terms of the number of examples that are given, number of solved exercises at the back. You can look at it and we can follow any one of them, or we won't have time to look at both. It doesn't make any sense because it's just full of different processes. Pretty much the principles become the same, and then it's repetitive. So if you can acquire, say, Felder and Rousseau book on elementary principles of chemical processes, John Wiley, that's also good enough. If you want a lot more practice, and I don't think it's required because you have so many courses, you can look at Himmelblau's book, which is fatter and thicker. Devpriya, have we completed what we are supposed to complete in class 1, or have I missed something out?
So I think we have completed what we had to do in class 1.
Right. Now, only one question is, I have only 16 names. You are the 16th. I have only 16 names here. So what is the, we are giving 10% for attendance. Is that all right?
Yes, sir. I think.
The thing is, I have a good memory for names and faces, but for the first time in my life, this is very faceless. So, now how do I get the, now this is saying it has 56 students. So how do I get the 56 minus 16 names that I have only 16 here in my this thing.
So pardon me, but I don't think that attendance policy is too good, as there are multiple reasons by which we can miss our classes, like internet connectivity, and there are many other issues also. So attendance policies, I don't think 100% accurate.
But it's only 10%, right? It's like saying, suppose we have 40 classes, each is 0.25. Well,
Yeah,
for a long time, I never had attendance, but my colleague always, next door colleague always used to have it. And in some way it will, otherwise, no, people will just, it just
so
helps.
but it is quite good in the offline classes, but in online classes, I don't think that it would be that much accurate as we can just start the class and leave it like if
Okay,
we
all
get
right. I have no problem. As I said, I only started this attendance business 2 years ago. And in fact, at IIT Kanpur, we never had a attendance policy ever. We never used to. It's. I mean, I'm still influenced by my alma mater. I mean, here we have toyed in IIT Delhi. We have flip flop. Believe it or not, I've been here 30 years. 30. It will going to be 31st year. Um, we have been through, so initially we didn't have any attendance policy, then attendance became compulsory. 75% and less means F. That was opposed a lot. Then they came up with the rule that you can lower the grade by 1/2 grade, which is not a fair thing. So A becomes A minus becomes B. Then they said, well, you can put 15. My colleague would always put 15%. I mean, in the last couple years that I've used it, it's 10%. Um, and then they said that, and I don't mind. But then the problem is, where do we put the? If we let us try it for the few times, let us see how the connectivity is. Let us say there is real major problems. I mean, let us see how many are the total number of students, because I have only, the Microsoft Teams only gave me 16 names. So
Sir, I'm not completely sure, but as I remember in the document which was presented to us before the start of SEM, it said that there could be no grading on the basis of attendance. As I remember, I'm not quite sure, but
yeah, that
I,
is probably, it makes sense. But my point is, where do we put the remaining then? Major is already 40. Minor is 30. There's only one. If there were two minors, we could have easily taken
So you
care of
could,
that.
so you could
20.
give some assignments, 2 assignments, maybe 5 marks each for grading instead if there is an issue with the attendance.
See, there's no point giving assignment after assignment. One assignment will not do, because the number of processes are so many. You will see, I mean, we are going to start with the simplest.
Yes, sir.
Then we are going to build complexity. उसका तो कोई अंत ही नहीं है. For instance, I will give you a very simple, I think we have a couple, yeah. So you have to think on two things. One is you have to do the dimensional analysis, which you've already done in high school and first year, okay? And I will test you on it next time. We will just discuss that. Let me give you a very simple question, one of the simplest I can think of. You have a process unit, okay, and you have, let us say, a gas coming in, and you have the same gas going out. So there's no reaction, nothing. There's just one species, the same one component, let us say a diatomic gas. And let us say we have a test to monitor the gas flow. Like you have a meter, like an oxygen meter or a rotameter, and you can monitor the flow. And you can, the densities, so you can convert them to mass flow rates also. So much of kilogram is going out per minute or per hour, right? Now, the common question we like to start with is, suppose you measure this gas mass flow rate at the inlet of the process. Nothing else is happening, the same gas is going on, and you measure this at the outlet. And let us say these numbers are not the same. You get different numbers, let us say, from the measurement. What could be the possible reasons? Is my question clear to all? Maybe Akshat Jain, is my question clear?
yes, sir.
You have a flow of gas at a certain rate, and you have a measurement to measure its mass flow rate. You do that same measurement from you have an experimental tool, let us say, or a meter. You measure it at the initial, that is beginning, before it enters the unit, and you measure it at the exit. And you find the two numbers are different. Question for you is, this is a good place to start our balance business discussions from. And then we can take specific examples later. The question for you all is, what could be the possible reasons that led to the observed difference in the numbers or in the measurements? Can you list those things down? Okay.
Like, sir, area of cross section, like.
We'll discuss this next time, but this is a good place to start our deliberations in this course. And then normally we should, of course, also do the different types of processes. So maybe we should do that after dimensional analysis, do the processes, then we can discuss this question. But you should think on that. Now, coming back to that 10%, I have no problem. And we can decide it in the next class, perhaps, on Wednesday. But where do we put it? I don't want to put more on the major or on the minor. If you want 30% for your presentation, that equals one minor then. It's all right. That means then I don't have to even worry about this attendance list, because I wanted to know who are the remaining of the 55. I just wrote down the 16 names. Now, earlier, I have a magic memory, so I remember names, faces better than any student till now that I have met in my 30 years. But now, it is all sort of faceless. So, but at least I wanted the attendance list complete. But if there is no attendance, honestly speaking, doesn't matter. So you need to decide. We have to decide. I just put 10. But if you think that there's a problem with connectivity, which is reasonable, I can understand that. If that is true, then we can put 30% for your presentation. 6 people, it's not difficult. So it's even equal to a minor. You have to do a little proper job on it. And you have to choose a proper process. You have to do preferably mass balance and energy balance, or if it's and then if it's a biological system, it's even more complex. We generally do not only the balance for components, we also do available electron balance, but that only comes later. We only do that in November, and so I don't know. So आप last minute में उसको करोगे तो फिर 30% काफी ज़्यादा है. So as long as you can build your, maybe what you can do is by in a month you give me the list of 6 students. It's up to you to form your group. I don't mind. It can be from the same hostel, your friends, whatever, because we don't want to force it down your throat. Many times at IITK they used to just do it alphabetically. And so you have to work with whoever is there. I don't know if that's a good idea, but you can. I suggest you choose your 6 and then you do a proper job. But give me the thing before end of October. Who is your teammates, and preferably if you can worry about a topic. If you want, I can help you with that. Then that would be 30. Otherwise, if you don't want to put in too much on the presentation, and you have to then have some synergy among 6 people. If you want to attend it, that is all right. Let us decide this on Wednesday. I have no problem. It's not a problem. So then it will be 40, 30, 30 or 40, 30, 20, 10, up to you. So I have left you with 2 questions for the next class. First, you are going to take the usual mass, length, time dimensions, and you are going to work out very simply on tabulate, or just do, if you already know it, wonderful. You're going to do it for the usual ones, starting from velocity, acceleration, force, power, etc. And then I can take any variable I want. You should be able to write its dimensions, and you should be able to tell me what its units are. There's so many properties in balances. We need, by the way, we need data, to solve these problems, right? Suppose it is energy balance, you need enthalpy data or free energy data. So we may need densities. We may need something else, some other physical property. So unke sare dimensions or units, anything I give, you should be able to do that. It's like what you have already done in physics, chemistry, and physical chemistry, and etc. And perhaps in chemical engineering courses, you must have done transport phenomena and thermodynamics in your first year, right? Akshat, you have done transport and thermodynamics, or you have not done?
So I don't like transport. I'm not quite sure. I've done thermo quite good.
No, I mean in first year you would have done that, right?
Yeah, in the CML course.
Oh, I don't know the abbreviation. What's that?
CML actually I don't know. Even I don't know. We just call it CML only.
See the
It
numbers.
was related to chemistry.
Sir, the transport phenomena course is now a second year course, so we are doing it.
Wow, it used to be a first year course. It becomes second year now. Yeah, very interesting, because we have changed all of this at least a dozen times in 30 years, at least. I finally stopped. I mean, I stopped. Every time the numbers change, the weightages change, 310, 300, etc., etc. I couldn't keep track. But that is one thing at IIT we used to do things differently. I mean, hardly ever it would change. We would decide it in the beginning, and there was a certain order which was kept always the same. So in a way, I still prefer that. I mean, and the founder of our department, Professor T.K. Ghosh, he was a great biochemical engineer. He just died at the age of 95. We are the first biochemical engineering department, okay, in IIT, among IIT systems. So he founded this department, and he was also of that opinion that we shouldn't keep on chopping, changing. There is a certain logical flow. Anyway, here there are many other diggaj log hain who have experience, who have designed curricula, uh, and this is also requires a lot of expertise, making curricula and all. It is not everybody's job anyway. But I no longer remember वो कौन सा फर्स्ट ईयर में, कौन सा सेकेंड ईयर में, वो कोर्स का नंबर चेंज है, सब कुछ kept on, because we have had many revisions. So either way, if you're doing it this time, whatever, I thought you would already know that. Okay, so you will anyway do the dimensional analysis, and you are going to worry about the question I asked you on why those mass flow rates were different at the inlet when measured and outlet. Why the numbers were not the same? What could be the possible reasons? Itna aap kariye, and then you will tell me about the attendance. If the attendance is not there, I'm not worried really on having a master sheet on it. That is also fine. Okay, Devapriya, Akshat, you will let me know next time. Any questions? We are at the end of our, I don't want to take more than the allotted time. Is the speed too fast, too slow, or too much loud, or too, ये बताइए आप. Loudness is okay?
Yeah, sir. I think it's perfectly fine.
Wonderful. And let us discuss this next time, and then gradually let us build complexity, and then there will be many interesting questions to solve, because we can actually solve these in class also if we want. It's up to us. So what we should do is, I'll take some examples, and then give you some things to also do. Okay, so we have started with one of the simplest things. इस पर आप सोचिए क्या explanation हो सकता है for the difference in the measured mass flow rates of the gas.
So just one request,
Yeah.
something I which notice in college particularly is that we don't get enough practice of the questions. So you please give us a proper practice of every type of questions. Like it gets easy when we get an example of every type of questions to get the knowledge of a topic. Like reading the formula won't help much, but getting a question on that formula helps rather much better.
Okay, quick answer to this. I am not a believer in this approach. I mean, this is the coaching class approach. Okay, we never had coaching when I took JE. Okay, I mean, so doing all, because always you have uncertain new situations. But yeah, we will do some classes of problems we can do. But every type of problem इसमें करने की कोई जरूरत नहीं है. Because you all you have to do is know the principles, work out a few questions, and then you have to do them in that time or in your project or whatever you call that 30% thing. So हर एक टाइप का प्रॉब्लम करना, आई मीन तेरा हिमेल ब्लाउज बुक अगर तुम करने लगोगे तुम दूसरे कोर्स नहीं कर पाओगे, इतने सारे क्वेश्चन है उसमें. बट आई दैट्स नॉट, I don't think that's a great philosophy, you know. I mean, why do you want to do that?
Not actually every question. I just meant just one example of each topic which we are going to discuss. So we get a rough idea of where
I
its
give you,
application would be actually.
we are starting with the simplest class of question. No reactions, no energy balance, no accumulation, just one component. है ना? Is there? We can do a typical example of one class. Yeah. So there is a suggestion for those 10 marks. Okay. What is it, Abhinav?
Hello.
Yeah, I can hear you. Very nice.
Yes, sir. Sir, we can take that out of those 10 marks, we can take 5 marks for attendance if it's okay with everyone. And 5 marks we can take up a assignment. Because 30 marks for just one thing is too much.
Let us just either we should give nothing for attend. Let us see. I mean, first of all, if everybody is able to log on to this, it may be a good idea to have it. If there is a problem कि log on ही नहीं कर सकते और कुछ सुना ही नहीं आता, because this is my first. As I said last semester, I did not have any online. I mean, I didn't have a course at all. So this is my first time. So let us just give till Wednesday or Thursday even. But 5% क्या 10% क्या, to me Abhinav it doesn't make sense. Either we should have 10 or nothing. That's what I think. And finally, you know, if no consensus is reached, I mean, I will decide. I shall decide. Okay. Finally, like a referee in a football match. By the way, I'm very much in. I mean, I was a finalist of Princeton Community Tennis Open. So I've played a lot of tennis at a competitive level. That was my huge achievement in the US. Anyway, so it's like a referee in football. He has the final say when to give a card, when to say give a free kick or etc. etc. And their decisions are final, right? So we'll wait till Thursday, and then 5%, 5% doesn't make any sense. Either we have it or we don't. Okay. All right. Very nice. Nice experience. I'm glad that the audibility is good. And then let us start these two questions on Wednesday. We'll start with these two questions. Okay, thank you.
Thank you, sir.
Thank you very much.
Jai Bholenath.